Go ahead. We got a lot more to cover before then. Yeah. Yeah. Nah, I always said homework. It's day one. And it's okay if you didn't hear me. It's in the announcement. Every single one that I put out on Brightspace, along with the link and how to get in there. All right. Nah, there's some people. There's some people in here that got 0% for homework. You know, like for real, for real. Yeah. Yeah. But y'all good with the homework? Nobody got questions? Everybody straight? All right. All right. Remember, the largest portion of your grade is homework, so. Mm-hmm. Like I've seen people who fail every single test, and because they did all their homework 100%, they passed. I'm just saying. Mm. Nah, not soon. We got a lot more left to cover. Uh, hopefully we do it before spring break. You know, that'd be really nice. Like a C, considering if you failed everything, you know? Yeah. I mean, look, just do your best. That's all I'm asking for, you know? If you can meet me halfway, give me a 50 on everything, right? And do all your homework, that's a B in the class. Easy. All right? Everybody aim for A's. No, you know? All right. Hey, let's recap a little bit, right? So, a method for producing solutions, right? Sure. So, in the case that the equation is more complicated, there is still a straightforward method to produce solutions, of course, right? Just recapping from yesterday. Remember, we wanted to find three solutions to this equation. And we said an easy way to do this was to just solve for one of the variables. In this case, we chose to solve for y, right? So I had two. Ooh, hold on. Oh, why this happening now? Come on now. Okay, so we had 2x minus 5y is equal to 10. And then what we did was we just solved for y, right? So I subtracted 2x from over here. What I do to one side, I do to the other. So now I have negative 5y is equal to negative 2x plus 10. And then I divide by negative 5. What I do to one side, I have to do to the other. Right? We did this already, so that's why I'm going a little fast with this, right? Negative is positive. 2 over 5x minus 2, right? And I remember I was saying to find the answer to this, we just do a little table of values, x and y. You choose whatever x value you want. I told y'all my favorite. I wanted to choose the denominator. No, no, no. This is when you have two solutions, right? Excuse me, two variables in a linear equation, right? Solving for that. All right. So I like whatever my denominator is. My denominator is 5 here. So I'm going to choose 5, 0, and negative 5 to eliminate the fraction, right? And all you have to do is just plug it in, right? So like y of 5 would be 2 over 5 times 5 minus 2. You already know the 5s will cancel. This becomes just 2 minus 2. Call that 0. Plugging in 0, you already know anything times 0 is 0, right? So 2 over 5 times 0 minus 2. That's just going to give me 0 minus 2. Call that minus 2. Last but not least, let's say that I had y of negative 5, right? This would be 2 over 5 times negative 5 minus 2. The 5s will cancel. So what would this turn out to be? This would be negative 2 minus 2. Call that negative 4. right? And bam, I have 3 points, right? That would work for this solutions that would work for this equation, right? Just recapping last time. All right. All right. So let's just pick up where we left off. I just want to recap the sauce real quick before we go on. All right, so finding solutions to an algebraic equation in two variables. To find solutions to an algebraic equation in two variables, this is how you do it. Step one, choose a value for one of the variables. Step two, substitute that chosen value into the equation and solve the resulting equation in one variable. The ordered pair corresponding to the chosen value with the value obtained by solving the resultant equation in an appropriate order will be a solution to the original equation in two variables. All right, that's the sauce right there. It's not on that. Yeah. Long story short, right? You're gonna have an equation and you want a couple of solutions, answers to that equation. You're gonna pick the values. It doesn't matter what you pick, you're still right, right? Pick whatever you want. And then when you plug in for one variable, you solve for the other variable. That's it. Yeah. So one thing should be clear from the method described in the example above. A linear equation in two variables will typically have infinitely many solutions, one for each choice of the value of x or y. This will present some problems from the point of view of solving such equations, finding all the solutions. All right? Uh-huh. Go up. Okay, let's go up. Okay. So last class, Carmen mentioned something that I don't really want to talk about, but we got to talk about it. Graphing. Right? Yeah, but we got to. Yeah. I mean, I assume everybody knows how to graph, right? Right? No? All right, we're gonna go over it. We're gonna go over it. Let's talk about it first before we do it though. All right. So graphing linear equations in two variables, right? So in the past section, right, on linear inequalities in one variable, we saw a powerful method for keeping track of solutions of algebraic statements with infinitely many solutions, graphing, right? Remember when we had that number line? We were saying like, oh, x is greater than 3, less than 5, whatever. So the same idea, but now we're gonna do it for two variables. So we're gonna have a whole Cartesian plane, right? It's gonna be a little bit different, right? So again, however, in the case of algebraic statements in two variables, a number line is not sufficient. To keep track of the values, of both variables, we use the XY plane, sometimes called the Cartesian plane. All right. After one of the originators of the concept, the French philosopher and mathematician Rene Descartes. Yippee. Look him up. Y'all might actually like his story, right? Especially if y'all into like religion and all that. This dude is a big contributor to religion. All right. Anyway, for the sake of reference, right, we list some of the most important properties of the XY plane, right? It is formed by two number lines placed at right angles and meeting where both are labeled at 0, right? So instead of just having one horizontal number line, we're gonna have a horizontal one and a vertical one. All right. And they're gonna meet in the middle at where 0 is. That's what it's saying. All right. So The number lines are called the x-axis. It's a horizontal number line, and the y-axis is the vertical number line, right? The point of intersection of the axis is called the origin, right? And at the origin, that point is 0, 0, right? Okay. The positive x direction is to the right. The positive y direction is up, all right? So what does that mean? The negative x direction is to the left, and negative y direction is down, all right? What's up, man? Huh? Yeah, I got you a little bit later. Hmm. Yeah, so positive x is to the right, like when you're increasing, right? Negative x is to the left, like when you're decreasing, right? And then positive y is up, and negative y is down, all right? An ordered pair is represented by a point on the xy plane by means of its coordinates. The first number, the x coordinate, represents the number of units in the x direction from the y axis to the point. The second number, the y coordinate, represents the number of units in the y direction from the x axis to the point. All right. So let's take a look at what I'm talking about. By the way, same deal as before. I know some of y'all bored over here. I could I could see the video games and the anime going on in the back. All right. Just do your homework. All right. Yo, man, there's always anime playing, man. Yeah. Always. What you watching then, man? What you watching, man? The Olympics is over, so I know you're not watching sports. Man, either that or Team Umizoomi. I don't know which one you watching, man. All right, so look, this is a Cartesian plane right here, right? So we got our x-axis right here, and we got our y-axis up top, right? Right here, this is the origin. If I plot that point in the middle, this is the point 0, comma 0. All right. If I want to plot any point, like let's say I want to plot the point 3, comma 2. I'm just making it up, right? I go across the x-axis to where 3 is, and I go up 2. 1, 2. So right here. This would be the point 3, comma 2. Right? Cross the x-axis for 3, go up the y-axis for 2. And that's it. That's how you plot a point. Questions on this? All right. Y'all have like 3 homework sets on this. Just plotting points. All right. One of them is like that, where they tell you to plot 3, 2, and you just go ahead and do it. There's another one where they'll have a plot like right here. And they'll be like, yo, tell me what point that is. For fun, tell me what point is this? So -3, +3. That's good. All right. That's it. All right. We still got more to talk about, but that's y'all homework. All right. Enjoy. Just to recap real quick, the points on the x-axis correspond to the ordered pair having 0 as the y-coordinate, and points on the y-axis correspond to ordered pairs having 0 as an x-coordinate, right? What the heck does that mean, right? So if I'm on the x-axis, let's say I'm right here, right? This point right here is -4, comma 0, right? If I'm on the y-axis, excuse me, let me say that again. Yeah, if I'm on the y-axis, let's say like right here, right? That point is what? That's 0, comma 3. That's it. Questions on that? Y'all all look bored, so that's good. All right. Boring is always good. I think this picture looks a little bit more pretty, so I want to use this picture instead. All right. So let's return to our example of x plus y equals 5. Just by inspection, we found several solutions. We will now represent each ordered pair solution with a point on the xy plane, right? So remember when we found our solutions to this equation yesterday, right? Here they are, plotted on the graph, all right? That's it. It is a line, right? Those are the 5 solutions that we found. This graph was obtained by plotting 5 solutions of the same linear equation in 2 variables. Points to a crucial fact that we will be centered, that will be central, excuse me, to our treatment of. Let's continue. Linear equations in 2 variables. Yay. All right, linear equations in 2 variables. All right, big fact. All right. The geometry of solutions to linear equations in 2 variables. The points corresponding to plotting all solutions to a linear equation in 2 variables all lie on a single line. Every point on the line corresponds to a solution to the equation. All right, so that's key. When I graph that line, every single point on that line is a solution. Go ahead. Mhm. Well, here's what it's saying, right? Right. Mm-hmm. That's what we're doing. Like we're finding a right. We're finding a way to find all of the possible solutions, right? So for example, with our x plus y equals 5 equation, right? If I connect all these dots, right? And I make this line right here, right? You could name the line, right? This would be what? Y equals what? Negative x plus 5, something like that. The point is this on this line, every single points on the line, even the points that you can't see, all of these points, right, are solutions to this equation. Every single one, right? That's what they're trying to say. Mhm. So this fact, combined with some basic geometry, gives a powerful technique to solve linear equations in 2 variables in the form of a graph. General method to graphing a linear equation in 2 variables. To graph all solutions of a linear equation in 2 variables, find at least 2 solutions, right? Step 2, plot the solutions. Step 3, draw the line passing through the chosen solutions, and that's it. That's how you draw or graph the equation of a line. All right? Very simple. Just find 2 solutions, connect the dots, call it a day. The dots need to extend past the 2 points as well. That's another thing too. All right, so notice that geometry. comes into the picture due to the fact, written down as far back as Euclid, that two different points determine a unique line passing through them. This fact is what allows us to buy two solutions, get infinitely many solutions free. Combined with our method for producing solutions to linear equations in two variables above, we are hence able to graph any linear equation in two variables. For example, let's graph this, right? Recapping again, I have 2x minus 5y equals 10, right? And then I'm just going to subtract the 2x from here. This is negative 5y equals negative 2x plus 10. Divide by negative 5, divide by negative 5, divide by negative 5. I'm trying to solve for y. So y is equal to 2 over 5x minus 2, right? And then remember we did our table of values. So what I'm telling you is I don't need to do three answers. I only need two, right? So I'm going to pick two easy ones, 0 and positive 5, right? When I plug in 0, you know that this is negative 2. When I plug in 5, this is what? 0. Real simple. So now let's make a Cartesian plane. This is x, this is y. All right. So now all I have to do is plot those 2 points. Call it a day, right? Use your BCC ID, make a line, and that's it. All right. So 0, negative 2, right? Come to the origin in the middle right here, right? And then I'm going to go down 2. 1, 2. Right? This is that point, 0 comma negative 2. This next one is 5, 0. Just going to come across 5. 1, 2, 3, 4, 5. And here we go. This is that point, 5 comma 0. All right. And then if you go ahead. Yeah, I picked it. I picked it. You can pick whatever you want. Yeah. But the reason why I'm picking it, right? When I plug in 0, that eliminates x. So it's whatever the y is left, right? So that's just the easiest point, right? That's the thing. I don't want to plug in 2 over 5, right? That's why you see me picking 5 because that's going to kill the denominator. Then it becomes just 2 minus 2, you know? Yeah. It is in the homework. It's there. Yeah. Huh? Chili? What do you mean? The Cartesian plane? Yeah. Yeah, the X and the Y plane. Yeah. So look, all you got to do, just connect the dots like this. And that's it. That's the whole graph right there. Right? Every point on this graph, right, is a solution to the equation. Right? Questions on this? I got work on it. Yeah. Just solve for y, and then just plug in two points. What's up, man? How are you? Pretty good. Yeah. Everything good? Yeah. Okay. Got you. All right. All right, no worries. Yeah, yeah, yeah. Okay. Yeah. I don't know, as long as y'all got y'all groceries, that's all I care about. Mhm. But the elevator is really bad and old. Yeah. 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 But yeah. Yeah, we got more coming. Yeah. Colson's not bad. Yeah. It is. All right, before like plug in values for X and see if they work. Just plug in values for X and see if they work. Yeah. In the equation, you know? Yeah. Before we jump into another example real quick, like let me just show y'all like a pretty graph. I know my handwriting not so pretty. There you go. That's what it was supposed to look like if done correctly. Right? So you got your 0, -2, you got your 5, 0, right? You extend the line beyond the 2 points, right? And that's it. All right. That's what I was attempting to draw. And that line represents all the solutions of the equation 2x minus 5y. It is important to emphasize that the last connect the dots, right, step, simplest from the procedural point of view is also the most significant. We have gone from 3 solutions to infinitely many solutions, 1 for each point on the line. All right, let's do some more. I got 3x plus 4y equals 12. Tell me what to do. I don't even know how to do this. Tell me what to do. Okay. So you're saying subtract 3x from over here? But what I do to one side of the equation, I gotta do to the other side of the equation, right? So what do I have now? Tell me. So, all right, 4y equals negative 3x plus 12. What should I do after that? By what? Not 4y, 4, right? Just 4 by itself. But what I do to one side of the equation, I have to do to the other side of the equation. So now what do I have? I have y is equal to negative 3 over 4x, all right? Plus, what's 12 divided by 4? It's 2? It's 3? Okay. All right. So now I want to graph this, but before I can graph this, I need to find two values, right? So I have x and I have y. Now, if you're thinking like me, what two values am I going to plug in for x here? No, not 3. Give me something better. No, give me something better. 4. Why you said 4? That's the one. That's the one I wanted to choose also because it's in a denominator. All right. So look right here. What happens when I plug in 0? Right. Let's say y of 0. This becomes negative 3 over 4 times 0 plus 3. You already know this whole thing is 0, so I'm done. So the answer is just 3. But what happens when I plug in positive 4 over here? Let's say y of 4. This becomes negative 3 over 4 times 4 plus 3. 4s will cancel out, right? So now all I got is negative 3 plus 3. Take out your calculator. What's negative 3 plus 3? What is it? 0. And that's it. You plot them 2 points and we done. That's it. All right. So I got you. Let's say 0, 3, right? So I go to 0, go up 3, 1, 2, 3. And then let's say 4, 0, 1, 2, 3, 4. And then just connect the dots. And we done. That's it. Mm-hmm. Easy, right? Mhm. We good? Everybody got the bottom also? Hmm? Think we have just like one more topic to talk about, and then should be good for all your homework. So I feel like there might be like one homework set that you might not know how to do. Well, we'll finish that on Monday. Anybody caught that Nick game last night? Caught that Knicks game last night? Anybody? Yeah, yeah. What I don't understand though, right? Um, Thunder's a good team, right? How the Thunder didn't blow them out, and then these other teams they ain't got like no record be blowing out the Knicks. I don't get it. I don't get it. Like they were, so I didn't even know I was here. I didn't even see the beginning of the game. They was winning. All right, that's not bad. But I'm talking about like 30. Yeah. Yeah, they came back. But what I'm saying is that there's these whack ass teams that be destroying them. And then when a good team just comes up in them, like they all of a sudden they can do magic. Like I can't explain the Spurs. Like I can't explain that. Spurs cannot win against them for nothing. But yet they got like what, 15 losses for the whole season? Oh, I can't explain that. You know? Yeah. True, true. So here's another one. Be our last example. Hmm. I give y'all like 2 minutes to try it, then y'all can walk me through how to do this. Oh, one last commercial break. I just remembered, right? So this Sunday and next Sunday, right? There's actually going to be tutoring if you guys want to go. It's going to be both in person and online. Whatever you guys choose that you want to do is fine. All right. I'll be there online this Sunday if you guys want to come online and meet me. All right. 12 to 6. Hmm. All right. I mean, the everything is still the same, like with the Saturday and stuff. They're just adding one more day for this Sunday and for next Sunday. All right. If you guys want to come. All right. All right. How I do this? I got y equals 1 over 4x minus 2. This look hard. What I want to do first. Hmm? Add 2? Not add 2. I want to find 2 points, right? All right, so we do our table of values. All right, give me 2x's. Say it again. 0 and what else? Oh man, that's what I'm talking about right there, right? So then right after that, you just plug it in, right? So let's say y of 0. You already know what that is. It's going to be 1 over 4 times 0 minus 2. This whole thing is just 0, right? So this is just negative 2. And let's say I say y of 4. This is going to be what? 1 over 4 times 4 minus 2. 4s will cancel. This will become 1 minus 2, which is negative 1, exactly. And that's it. Just plot that and you're good to go. All right. I have a little Cartesian plane here. This is my X, this is my Y. And by the way, right? I know I'm picking these special numbers and stuff, right? You guys can pick whatever you want for X. All right. I'm just bad at math, so I gotta get rid of fractions and all of that. Right. And I gotta plug in stuff like zero, you know. I'll be struggling with my timetables, you know. So just plug these in, get your numbers. So this is 0, negative 2. So I start off at 0. All right, gonna go down 2, 1, 2. Next one is 4, 1. So I'm gonna go across 4. 1, 2, 3, 4. Go down 1 right here. So this is 0, negative 2. This is 4 comma negative 1. You already know. Connect the points. And that's the end of the story. Questions on this? Go ahead. Let me see. Let me see this one. Also, here's what you do, right? Everybody can do it. You see, like with the negative 4, you plug it in, and if it works, good, yes. If it don't work, no. That's it. Only the 4? Well, for all of them, right? Just plug in the X into it. And if the Y value comes out, you good. If it doesn't come out with something different, then it doesn't work. Yeah, it's just a yes or no question. Yeah. All right.